Well, I'm very pleased to welcome Sir Eric Ashe here. Sir Eric is one of the most eminent electrical engineers in the country. He is currently Treasurer of the Royal Society, and he was the Rector of Imperial College for a very good time during the life of Imperial College. Welcome, Eric. Is there anything in your success which is most palpable and visible that you would trace to the influence that Dennis Gabor had?
We're all children of our parents, and certainly children of the person who supervised our PhDs. So the answer must be yes. But of course, I don't aspire to any of the successes that Dennis Gabor achieved in his lifetime. But yes, I gained a great deal from working with him, and particularly the way he was prepared to look at problems which had no obvious solution or purpose.
Of course, you were his first PhD student, if
That's
I remember
right.
correctly. Was that a difficult decision to make?
No, I think not. Incidentally, when you say I was his first student, there were three of us actually who were started simultaneously. But it was not a difficult decision. His reputation preceded him. We had, of course, read some of his distinguished papers, and he was in every way a totally fascinating man, and was very glad to have a chance to work with him.
Was it at all difficult at any time?
Oh, sure. He was not an easy person to work with. I suppose the biggest problem was that he was so very much more intelligent than anybody around him, and I think it was quite difficult for him at times to appreciate that ordinary mortals couldn't jump as rapidly from one idea to another as he could. So that took a certain amount of adaptation.
Yes, I imagine that could be quite tricky with. And those days were different. Supervisors behaved in different ways. They didn't have this schedule of having to see their students for an hour every week.
Well, I'm not sure that it was really so very different. Maybe it wasn't officially imposed, but certainly the contact that we had with Dennis Gabor during that time was very close.
I understand he'd just pop into the lab and
Absolutely. Yes.
take part in things.
He would take part in things, which was always a rather dangerous thing to allow him to do, because although he was a very brilliant scientist, he was not entirely safe in a laboratory.
Was he? Did he treat his research students as friends or as somewhat lesser beings?
I think he tried to treat us as friends, but he was not a totally relaxed individual. He was in a sense a rather private person, and I don't think he found it terribly easy to communicate across what seemed at that time like an enormous age gap. Looking at it now, of course, it was not as dramatic as all that.
We are, of course, celebrating his centenary year, and how would you sum up his contribution to that particular century? You wrote an often quoted obituary of Dennis, and whilst you pointed out that holography is the great headline, you also pointed out that his contribution was much greater than that.
Indeed it was. It was certainly very much wider. I mean, holography is no doubt the pinnacle of his achievement. It was a remarkable and brilliant invention. Perhaps we'll say more about that in a moment. But he did participate in a number of other fields of physics and contributed massively to them. And he was a pioneer of several other fields of physics, notably communications theory, at a time when people didn't even understand what those two words really meant.
How did that square up with the work that was being put forward on communications theory by people like Shannon and Norbert Wiener? Did he see himself part of that, or did he just have his own ideas?
He saw himself as part of that. But in fact, his papers were almost at the same time as those of Shannon. I'm not quite sure of the exact chronology, but he was very much a pioneer at the same time.
Right.
And of course, Shannon made the supreme step forward in communications theory. But Dennis Gabor certainly contributed greatly to it, and very greatly to the concept of learning machines, which of course is a field that you know all about.
We all have beautiful flat screens on our laptops nowadays, but this was something that Dennis Gabor was really interested in, because in those days it seemed to be impossible to flatten the cathode ray tube, and yet he more or less did it.
He did more or less do it, and he invented a most ingenious electron optical system in order to do this. And the problem with an ordinary cathode ray tube is you have a gun at one end and a screen there, and you have to have a certain distance between them so that you can deflect the electrons to the spot where you want them. He decided the way to get around this is to have an electron beam which ran almost parallel to the screen and which was deflected in an ingenious way to hit the right spot that way. It was a difficult thing to do, and it had some important technological problems. Like, for example, if you have a really flat piece of glass, it doesn't resist the pressure nearly as well as if you have a curved piece of glass. So it was bristled with problems. Nevertheless, some years later, Sir Clive Sinclair actually tried to make one of these things and produce them. And I believe he had a certain amount of success in actually making them work, although it didn't actually, in the end, turn out to be a commercial proposition. And of course, then liquid crystals came along, and they are vastly better.
If we go back in time a little, what do you know of Dennis Gabor's early days and his early education?
Well, I know basically what is written in a remarkable Notes and Records piece for the Royal Society by Professor Allebone. But he came from a very cultured family in Hungary. He spoke Hungarian, of course, but also English and French in a fairly natural way, although his accent in English was not always easy to penetrate, but his command of the language was, of course, superb, and I gather had been from his youth. He knew a great deal of mathematics, even in his school days. In fact, by the age of 16, he knew all the mathematics that he would have required in university when he went there, and certainly all of the electromagnetic theory that went there. So he was quite brilliant at that age.
So one of his early contributions was the idea of an electron lens. Was that developed in any way?
Well, it was certainly he was a pioneer of the use of electron lenses, but he also made a major contribution to the actual embodiment of the idea. In particular, at the time that he started on it, a simple coil was recognized as a focusing agent, but he showed that by encompassing it in iron, by concentrating the field, you could make it much more effective. The actual idea of this being an electron lens was not his. This was, came from a celebrated paper by Bush just a little later. But it is a fact that the lens that he worked on and produced was used in the first electron microscope.
That's, of course, a milestone in the advances in science of the last century.
Absolutely. Yes.
Then he was involved with Siemens.
Yes, he moved from the Technische Hochschule in Berlin to Siemens, and there he was involved with work on plasma, and in particular the idea of making a new form of fluorescent light using a plasma in a different embodiment. That didn't quite come off, but it was important for one particular reason, and that is when there was a good reason for leaving Germany, namely 1933 with the election of Adolf Hitler. His work in this field was known, and particularly known to Professor Allebone, who then rapidly recruited him to the UK, where he started work in a research laboratory which is now part of Marconi, but was then called BTH.
BTH Research Laboratories. And he spent some time there before coming to Imperial College, presumably.
Oh yes, he was there until 1949, so he must have been there for well over a decade.
And he was recruited here, I think, by Willis Jackson.
He was recruited here by Professor Sir Willis Jackson, and it was a very remarkable bit of talent spotting on the part of Willis Jackson.
Yeah. You yourself were an undergraduate at the time, presumably, when he came in, or?
No, I was just about to graduate. In fact,
Right.
I had done 1 year towards a diploma of Imperial College on a totally different subject to what was my subsequent Ph.D. work. But I then moved over to Dennis Garber's supervisor as soon as he came.
Of course, when you were rector of Imperial College, you were kind enough to ask me to be the Gabor Professor, which was an endowment from Andrei Gabor, who was Dennis's brother.
That's
I
right, yes.
understand that they did some work together.
That's right. There's one paper published by the two of them together. Andrei Gabor was an economist at the University of Nottingham, and the paper they wrote together was entitled The Mathematical Theory of Freedom. Absolutely fascinating way of looking at the concept of freedom from a mathematical point of view. I don't think it would have occurred to many philosophers to do it that way. And it got highly mathematical and with some rather intriguing results. Now, I don't believe myself that if we think of some countries that are short of freedom, that reading this paper will convert them, but it was nevertheless, from an intellectual point of view, a remarkable new way of looking at it.
So how much were his other contributions, for example, in information theory, generally recognized?
I think not too much. Although he contributed greatly, and I think people recognized that he had been a pioneer in this, I don't think it somehow rather made the headlines. And that, in fact, was true of a number of areas in which he worked. If I can give one example, sure. He was very interested in the discrete energy loss that electrons suffer when they are transmitted through a thin film. And he had a theory as to what this was all about. It was based on the idea of plasmons in the metal. And I remember attending a seminar here at Imperial College where he decided to advance this idea, mainly amongst physicists. And they were really rather angry with him. They didn't really like the idea of this thought being injected into what they thought of as their field. It was a little bit of a demarcation dispute. And yet, that has turned out to be essentially the correct explanation for the discrete energy losses.
And that was published and recognized?
Oh yes, yes,
yeah.
Indeed.
Most people will remember Gabor outside of holography for his name being associated with Gabor filters and wavelets and things like that have cropped up in the literature again. Is that something that he seemed to be excited about at the time?
Not at the time that I was there. I heard about it subsequently, so I'm not a good witness.
Right. He was also very interested in societal issues. How much of that did he discuss with his students, or were his students aware of?
I certainly had some very interesting discussions with him on that subject. And right from the time that he first came here, he was much concerned by the way society was moving, and in particular the population explosion, which concerned him greatly, as indeed it has concerned everybody who's ever thought about it. And then, of course, he actually wrote a celebrated book, Inventing the Future, yes, in which he developed all the ideas that he had about how society might be shaped in the future.
Right. Was there anything that you think was particularly remarkable about his thoughts on holography? Because I've always seen it as an incredible piece of foresight without knowing what types of light sources would be available in the future. And this is not only my opinion, but everybody quotes that. Is that a mistaken idea, or is it?
No,
real?
I think it's absolutely correct, and it just shows how somebody with the imagination, the genius that Dennis Gabor had, can ignore the fact that there are practical problems in the way of an invention and pursue them anyway. But of course, his main purpose in inventing holography, the thing that stimulated him, was electron optics. It was in fact because he had been working at BTH research laboratories on improving the electron microscope and had appreciated that there were limits to the extent to which you could improve it. I mean, this is perhaps too technical, but I mean, the main problem is that in an optical microscope you can correct for aberrations by using different glasses because they can have different signs of the aberration. That just doesn't work in electron optics. There's something called Laplace's law which actually stops it working. And so he puzzled about what one might be able to do about this. And in the end stumbled on the idea that if you can't make good lenses, you're better off not to use lenses at all. And that's what then led to holography. And what he really wanted to do is make holograms with electrons, using the wave nature of electrons. Well, that was way beyond the time that anybody could reasonably attempt to do that. And indeed, it's only been, I think, in the last 10 years that in Japan some successful experiments have been conducted on electron holography. Right. But the basic idea was to use electrons and then reconstruct the hologram with light, and in this way gain the magnification without losing the resolution.
Do you feel that holography has been exploited to its limits?
Oh, certainly not. I mean, I think holography is a rather general principle which has applications in really all branches of physics, and maybe in branches of biology too. I think there's a great deal about holography which still remains to be developed.
Any specific areas?
If I knew, I'd try it myself.
You'd buy shares in it if you knew.
Right.
There was not only inventing the future, but also the proper priorities of science and technology. Is that something that people should be recommended to reread?
Absolutely. It was way before these issues were generally recognized as being key problems of our time.
So here was a man, a multimath by all accounts, who made a tremendous contribution to the last century. He's highly celebrated in Hungary, and we are having joint celebrations with Hungary about his centenary. How much do you think the British public have ever known about Gabor? The British public aren't all that good about knowing about Nobel Prize winners. Do you think he's sufficiently well known in the UK?
I think he's very well known amongst scientists and engineers. I don't think he's well enough known by the public at large, but that isn't his fault. I mean, it's not just the UK. I mean, the contrast is not just with Hungary, I should say. If you look at any town in Paris, any street in Paris, you've got a good chance that it's in honor of a scientist or at least some cerebral giant of some sort. On the whole, we don't name our streets that way here. It's not a tradition for us to celebrate excellence in intellectual excellence quite in the same way. And it's something I'd love to see changed.
Maybe we should name a street in South Kensington after him.
What a good idea. Or even within Imperial College.
Is a way in which you feel Gabor's life and your interaction with it could be summarized?
Well, my interaction was an extremely minor part of Gabor's life, so I can only see it really from a personal point of view.
Sir Eric Ash, thank you very much.